So let's talk about Scala 3. So this presentation is not Java, but Scala 3. So for example, we have such a list in Scala. You can see here we define a list of type int and then just assign it to some list which contains 5 elements: 1, 2, 3, 4, and 5. Then we can actually define another list of strings, which contains, for example, three items. We can do this in Scala, we can do it in Kotlin, we can do this in Java, but the syntax will differ. But the main idea is that we can define lists which contain some specific type. So for example, in first, we have this list of type int, and the second is of type string. And also we can define a class which contains some data. In Scala, we define case classes to hold data within the objects. So for example, we can define a class address with country, city, and street, and optionally add some more specific fields, for example, street number, street name, I don't know, and so on and so forth to describe the actual address as it is in. So for example, some person has address in some city, and we can create a list of such objects, of such addresses. So here we can see a Scala syntax of creating a list that contains objects of custom type, which is list of addresses. Note that all of these lists are typed as one type. First list is typed int, which is integer, which is whole numbers. The second is string, and the third is address, which is custom class. But in Scala, we can actually define lists not only of one type, for example, whole numbers, but we can actually combine types within the single list, so that when we declare this common list variable named as common list of type list with parameters int, string, address, we can think of it as a list that can contain no elements. It can contain only elements of int, which is whole numbers, only strings or only addresses, or we can combine in one list. For example, we would define 5 integers, and then 6th and 7th element would be of type string. So here we are okay to, for example, create such a list. On the second row, you can see list contains the first element is whole number, which is integer or int in Scala. The second is string, and the third item within the list is of type address, which is case class that we've seen in the previous slide. And what we can do with lists, we can iterate over lists, so it can be done as a for loop. Here you can see. So this is something specific to Scala. I didn't see that, for example, Kotlin or Java would provide such a syntax of union types to combine elements of different types within a single list. So here Scala is on top of the languages like Java or Kotlin, even Kotlin. So Scala 3 can provide such a cool syntax to define. So I think Scala is, in this case, is the most flexible language. And also in Scala, we can define actually two tuples instead of lists. So as you can see here, list can contain different elements of different types, but we can actually do even simpler. We can define tuples. So tuples are just, it's just a container of some data. So we can hold data within this container, and this data can be of different types. And we do not need to specify types for it. We just define the data itself. So for example, we can define such a tuple which contains three elements, three members of it. The first is integer, the second is string, and the third is just an object of type address. And note that we can omit the type declaration. So Scala compiler will understand that this tuple is of type tuple that contains integer, string, and address object. Note that we can hold in this tuple objects or values of different types if we wish. And how can we actually access the tuple elements? We can go by simple syntax. As you can see, we just get in the elements like that. So the first is here, the second is here, and the third is here. And what we can do with tuples, so imagine we are creating some kind of test or method with some data that is mocked data. We can define this data in the Scala file. So we are creating a list of tuples. Tuples have the same structure, and then in the very low we can see a for loop with pattern matching to destructure these tuples. So we take this tuple list, and one by one we destructure the tuple and then print into console. So you can see I draw some lines just to illustrate that each element gets on its position ID. So ID would be 1, 2, 3. Fruit would be apple, banana, orange, and so on and so forth.